Okay, so let's start on this sampling distribution proportion practice. Let me just kind of do a quick reminder to you of the formulas. Remember that the center of all of the p-hats will be centered around the population proportion. So whatever they say, the population is centered around, all of your p-hats will be centered around that. Okay. And then the standard deviation of all of those p-hats will be this formula. Okay? All right. I think number one is pretty straightforward, and it's got the two percentages and everything in it. So I hear you guys are kind of wondering a little bit about number two. So let's do that one together. Here we go. All right. So of all the cars on the interstate, 80% exceed the speed limit. Okay, so that's the claim, that 80% exceed the speed limit. What's the probability that a random sample of 50 cars traveling on the interstate contain less than 32 exceeding the speed limit? Okay, so let's kind of start going through there. What is this 80% exceed the speed limit mean? That's the population. That's what they are claiming for all of the cars. So that will be my right here. 80% of the population of cars on the highways on the interstate speed. Okay. What's this 50 random sample of 50 cars traveling? Okay, so that is your N. So we're talking about samples of 50 cars. Okay, so I'm going to kind of give you a little sketch of what's going on. We've got 80% of cars is where the population should be centered around, and we got all these little samples of 50. So here's a sample of 50 and the proportion of them that are speeding. Here is a sample of 50 and the proportion of them that are speeding, and so on. So these are samples of 50 and the proportion of them that are speeding. So what does this 32 play into? What is that doing for us? That is going to be used to give us p-hat. That's not actually the p-hat, but that's used to give us the p-hat. So what is the sample results that they got? When they took a sample, what results did they get? They got 32 out of the 50 were speeding, and that's a proportion. They got 32 out of 50 were speeding. So that is 0.64. Okay? All right, so that's what that 32 is doing for you. That's going to be used because that was sample results. Okay, so let's go back here and fill in these other things. What will the center of all the p-hats be centered around? Or what should it be? Yes, it's always centered around this. So whatever this number is what will go right there. Yes. No, that's a good question. Not as far as it being less than 30, we don't put one number less than. You just go ahead and you put that number 32 over 50, and then the area that you compute will be like right there, just a little less than it, and go down. In the normal model, we don't really dispute over the exactly equal to or not equal to. Okay? Now, what are we going to have to do here for this standard deviation, though? Very good. Perfect. So the square root of p, so I'm going to go ahead and fill in the numbers. What is the value of 1 minus p? Or p, yeah. 0.2, excellent. Okay. Over n, which is 50. Okay. Okay, so we got 0.0566, and if it's 0.0566, let's talk significant digits here. I want 2 significant digits. That means I want it rounded to this second spot here. So what will this 6 here make that 6 do? Go up. So it should be rounded to 0.057 as your standard deviation. Okay? Very good. So now that we've got that information, essentially, here's what we're doing. We're saying, I got a p-hat right here. Oh, that's a poo. I got a p-hat right here, and that's 0.64. And I want to know the probability of getting this sample result or less. Yeah, it says less than that. Okay, see, so I'm wanting to find a p hat located right there at 0.64 or less. So to get a z-score, remember it's p hat minus the p over the standard deviation of p hats. So what's that going to be number-wise? Mm-hmm. Very good. Over 0.057. And that is negative 2.81. Now, should that number kind of alarm you, by the way, just because of our knowledge of standard deviations? What do you think about a standard deviation negative or z-score of negative 2.81? Yeah, how do you know it's considered unusually low? Because it's more than 2 standard deviations below. So if you got that sample, you might start wondering, I wonder if that area really has 80% speeding. Maybe that's a speed trap and people know not to speed in that area, you know, or something like that. It's there at Micus Road. Okay. So let's now compute that area because that's what it said. What is the probability? So I will norm CDF the area below that, which means I'll be going from negative 99 up to negative 2.81. And that decimal is 0.0025, so it is very small. And so now let's do that special notation that I am wanting you to do. Let's practice that right now. So how will that special notation look? So I found the probability that I get a p hat that is less than. You can put either 0.64 here or 32 over 50, either, or you could put 0.64, either one of those, okay? So the probability that you get a p hat less than that 32 over 50 that I was talking about was how much? 0.25%. That's just a fourth of 1%. That's teeny tiny. So would you be surprised and think, so say you're taking this around the Micus Road area where you know it's a speed trap. Do you think 80% of cars around that area speed on average? Do you think the average of speeding around that area is 0.8 if you found this sample? Probably not. Yeah. Because if I'm getting a sample way down here, I'm calling into question this 0.80 because that seems too high. But anyway, got that? Okay, so there you go. By the way, one last thing I wanted to do vocabulary-wise before I stop and let you guys finish doing these problems. Why are there all these different p hats? What makes all these different p hats in all these different, to get all these different samples? What is that called? There is variability, yes. It's sampling variability. So we're getting all of those different p hats. So this is just kind of planting a seed of some vocabulary because of sampling variability. So sampling variability happens because you got different data than me. Okay, so you got different data than me, so that's why you have different p hats. All right, so our assignment then is to do pages 5 through 10. We, I believe on the calendar, have slated to do that for today and tomorrow, but we'll see how far you guys get and such. Maybe we don't need tomorrow. So, all right.